Hello, welcome to 2-4 Day 1 Notes. We're going to be learning about the chain rule today, which is the most powerful rule when it comes to calculus. And the main reason why it's the most powerful rule is because we are now going to be able to find the derivative of composite functions. Sorry, that was hard for me to get out. It is a little painful. We are going to be spending 4 days on the chain rule alone. So this whole entire week is going to be all dedicated towards the chain rule and mastering it. Alright, what we're going to do together here is we're going to go through this list of functions and we're going to circle the ones that are the composite functions. Remember, that means two functions that make up a whole entire function. So circle the composite functions below. This very first one, y equals x squared plus 1. Would not be considered a composite function. What about the one right to the next of it? Y equals sine 6 times x. This would be a composite function. It's made up of 6 times x, which is on the inside, and then the outside function would be sine of x. Okay, y equals 3x plus 2, not a composite function. Y equals tangent squared x. This is a composite function, and we're going to come back and talk about it in a couple of minutes. Y equals sine x, not a composite function. Y equals parentheses 3x plus 2 raised to the 5th power. This is a combination of two functions. You have your inside function, which is 3x plus 2, and your outside function, which is taking that and raising it to the 5th. Y equals tangent x, not a composite function. And then last but not least, you have this one, y equals radical x squared plus 1. Your inside function, x squared plus 1, would be the beginning function, and then the outside with the radical would be your outside function. Okay, what we're going to do now is I want you to think about composite functions having an inner part and an outer part. So you know what a composite function looks like. Y equals f of g of x. And it has an inner part and it has an outer part. And what we're going to do is we're going to take apart those inner and outer parts. So we're going to define this inner one as u. So we're going to say u equals g of x. And then we're basically going to rewrite this function now using u instead of the g of x. So then we're going to write that this would then be equal to y would equal f of u. The original function would now be in terms of u. And then at the very end we're going to substitute this back into the original problem, and then we'll have the derivative. So let's talk a little bit more about decomposing each composite function. This is what we're going to be doing at the very first part of our classwork. So you're going to look at each function, and then we're going to decompose it. I want you to identify the inner function as u and the outer function as f of u. So looking at letter A, y equals parentheses 3x plus 2, parentheses closed, raised to the 5th. This would be our inner function. So we're going to set u to equal 3x plus 2. And then what you're basically doing for the y part is you're taking out that 3x plus 2 and substituting in a u. So your y is going to equal u, and it's raised to the 5th power. Now you could write this as y equals u to the 5th, or you could write it as f of u, a function of u, is equal to u to the 5th. We're going to have to eventually write it like this below, so it makes a little bit more sense to go ahead and start writing it now. Okay, now for the second one, we have y equals radical x squared plus 1. So we're going to set u equal to the inner function, which is x squared plus 1. And then the outer function, it's basically taking out x squared plus 1 and putting u in it. So you could write y equals square root of u. Or again, you can learn to start writing it f of u equals u to the 1/2 or radical u, either one. Okay, now we have sine 6x. So that's made up of two functions. You have your inner part, which is 6 times x, and then you have your outer part, which is the sine function. So u is going to equal 6x, and then f of u would equal sine u. Plain and simple. Okay, now remember what we were talking about this one. What you want to do with this is you want to rewrite y equals tangent squared x as tangent x squared. You can rewrite it just like that. So what we actually have, u becomes a little bit easier to find. The inner function would be u equals tangent x. And then the outer function, if I take u out, or if I take tangent x out and replace it with u, I get f of u equals u squared. Pretty simple. Alright, let's look at this actual chain rule. If y equals f of u, which is what we were just doing, and u is equal to g of x, then the derivative with respect to x of the composite function, that's what this means right here, the composite function, is equal to f prime at g of x times g prime of x. So what this all means is the derivative of a composite function is the derivative of the outer function at the inner function multiplied by the derivative of the inner function. So what we're going to do, this is just another little way of saying it, it's a little bit easier of a way. So the derivative is equal to f prime of u times u prime. So let's use this one down below because it makes it a little bit easier because we're going to be writing everything as u. Alright, so here's an example. Find each derivative using the chain rule. What we first need to do is go through and label what u is equal to and what f of u is equal to. So u equals 3x squared minus 2, and f of u is equal to u to the 5th power. And what we need to do for each one of them is find the derivative. U prime would equal 2 times 3, and we're going to minus 1 away, so that's 6x. And then f prime of u, again using our power rule, bring the 5 in the front, 5 times u to the 4th. Okay, now what we're going to do is we're going to combine it all. So we're going to do y prime is equal to f prime of u times u prime, using the chain rule. So we're going to take and we're going to plug in f prime of u, 5 u to the 4th times what u prime is, which is 6x. Okay, well we can't have a function with a u and an x. So what the very last thing we have to do is substitute what u is equal to. And that's written up here. As long as you write that out, that's going to be easy every time you get to it. So we have 5, and then u is going to become 3x squared minus 2 raised to the 4th times 6x. And the last thing you can do is look to see if it makes sense to combine those. And it makes sense here to combine them. When it wouldn't is if this said, 6x minus 1. Then they would kind of want to see it in factored form. But this is simply just 30x parentheses 3x to the 2nd minus 2 parentheses closed raised to the 4th. And that is the answer. Alright, let's go ahead and let's try this one over here. Okay, we've got y equals radical x squared plus 1. The very first thing we're going to want to do is rewrite this as x squared plus 1 raised to the 1/2. And now we're going to go through and label each inner and outer function. So the inner function is what's inside of here, u equals x squared plus 1, and the outer function, which is f prime or f of u, you're basically taking out x squared plus 1 and substituting in the u. So we have u to the 1/2. Alright, so we're going to find the derivative of each. U prime equals 2x. F prime of u equals 1 over 2u to the 1/2. We've done this several times now, so you should be masters at being able to do the negative reciprocal all underneath at the same exact time. If not, you can ask me when we get back to class on how I came up with that. Okay, now what we're going to do, we're going to find y prime. y prime is going to be equal to the chain rule, which is f prime of u times u prime. So y prime equals f prime of u, which is 1 over 2. Instead of writing u this time, I'm going to go ahead and substitute in what u is equal to, which is x squared plus 1 raised to the 1/2, and then u prime is 2x. So I'm going to clean this up, and as you can see, I have a 2 on the bottom and a 2 on the top. So those are going to cancel, and I'm left with x over parentheses x squared plus 1 raised to the 1/2, and that would be my answer. So hopefully you're understanding this. It's just a lot of little tiny rules all combined together. It's really not too bad yet. Okay, let's go to this last one. You know what? Let's go ahead and make this one a you try. You guys go ahead and try this one on your own. See if you can do it without my assistance, and then we'll come back, or pause the video, and when we come back, the answer will be up. Okay, here's the answer. Hopefully you guys got negative 4x over x squared minus 1 raised to the 3rd power. If so, you should give yourself a big pat on the back. Alright, let's move on. Okay, you've got this general power rule that we used before, and now we're going to see how you were actually doing it the whole time. It's just now it's going to look a little different because we're going to be doing the chain rule with the power rule. So what the power rule is, what you're going to do is it's simply n times u raised to the n minus 1 and then times the derivative of u. Okay, let's go ahead and go down to this example number 1 down here, example A. And we're going to find each derivative. We're going to be using the power rule. And the first thing we need to do though is go and actually find our u. U is going to be equal to what's going on the inside, what's being raised to the power. So we have 3x minus 2x squared, and then the derivative of u prime is equal to 3 minus 4x. And then we're going to use the general power rule. F prime of x is going to be equal to, remember we bring him down in front and then we subtract 1 away from him. So we have 3 times u raised to the 2nd power times u prime. So taking out u, putting in what we have for u, which is 3x minus 2x squared, I get 3 times 3x minus 2x squared raised to the 2nd times u prime, which is 3 minus 4x. And you're probably going to want to leave it looking like this. You can, if you want, multiply the 3 into here, but for the most part, they like to see more factors, and the way you have it right here, everything is basically factored out, so it looks pretty good this way. This would be our final answer. Okay, let's go on to the next one. Alright, with the next one, what we're going to do is I'm going to show you how we were doing this exact same rule the whole entire time. So with this one, again, we go through and set u. U is equal to what's being powered, or what has the exponent, and that's just x. So u is equal to x. U prime would be 1. And then we're going through and we're going to use our general power rule. F prime of x is equal to 2 times u. Oh, I forgot the 4. There's a 4 here. 4 times 2 times u raised to the 2 minus 1, which is 1, times u prime. So going in and substituting everything, we would have f prime of x equals 4 times 2, which is 8, times u prime, or sorry, u to the 1st, times u prime, which is 1. So I would get 8x, which is the exact same thing we did before with the power rule. If we had f of x equals 4x squared before, all you would do is just bring that down, 4 times 2, and then subtract 1 from there. 4 times 2 is 8, x minus, or 2 minus 1 is 1. So as you can see, we would have gotten the exact same answer. So you've been doing this same rule the whole entire time, just now we're doing it with composite functions. Okay, what I want you to do now is I want you to try this one on your own. See if you can do it. And remember, we need to first rewrite this, just as a little pointer. We need to first bring him up to the numerator and rewrite it. So we would rewrite it as -7 parentheses 2t minus 3 squared. Negative squared. So let's rewrite it like that and then see if you can try it on your own. Go ahead and pause the video. Alright, hopefully you guys got 28 over 2t minus 3 raised to the third. If you did, you should give yourself a big smiley face or a big pat on the back. That's really, really good. Okay, tomorrow in class we're going to be doing a couple of these problems where we're rewriting them, writing u equals and f of u equals, and then we've got a couple of derivative problems that we're actually going to go through and do. Okay guys, hope you're having a fantastic weekend and we'll see you in class tomorrow.